Okay, so let's continue with our topic, binomial expansion. So in our previous lesson, we looked at Pascal's triangle. We used Pascal's triangle to expand binomials. So to this lesson, we are going to use another method, which is called what? Combination method. That's what you are going to use. So in our previous lesson, I told you that whenever you are given a question, when you are given binomials to expand, it is not only Pascal's triangle that can be used. We can also use this method, what we call what? Combination method. Not even only combination method, we have other method that in our next lesson we'll be talking about it, and we'll look at how we can use any of them. So in case in exams when you are restricted to use any of them, you'll be able to know how to go about the question. So this is combination method. So we'll not waste time. Now let's take our binomial. So we have this a plus b to the power of n. So let's look at this binomial. I've already told you that it is binomial because it involves two terms, only two terms. So we have this as the first term, and this is what the second term. That's why we say what is binomial. Good. So we are going to look at how we are going to use combination method to do this expansion. So this one we are going to use this formula. So I would be happy and I will be okay if you look at it critically, observe it. If you don't understand anything, you can go to the comment section and ask any question you want to ask. So this one for the combination method, we can write it as n combination. So we start with 0. That is what we are starting with. So this is the combination. This C you see here is combination. If you take your calculator, you see this combination there. Those of you doing elective maths, you know what I'm talking about. So this is what? N combination 0. Then we start with our first term, which is A. You write A, and then we begin with what? The exponent, which is n minus, because we are beginning with 0. So let's write 0 here. Then we add what? The second term, which is b. Good. Then that one to exponent what? 0. Now, as we are moving along, I want you to observe it critically and then tell me what you see. So we are done with the first term and move on. Then n combination. So what do you think the base will be since we started with 0? So the base will be what? 1. And then a. Then this is n. So this time we wrote 0 here. We wrote 0 here. So here will be what? 1. Good. And then the b exponent what is also 1. Good. Let's write the next term, which is n combination. So if here is 1, then here is automatically what? 2. And then we have a here, a exponent n minus, then here was 1, so here becomes 2, and then the b exponent will also be what? 2. Now, as we are moving along, you will see that the base of the combination is the same as the exponent of the second term. Have you gotten that? So if you can see, you can see that it is running through, and even what is here also is the same as the base. So you can see that it's running through. So this one too, it also what follows a pattern. So if you understand what you are doing, it becomes very easy. So I don't see why most of the time students complain that this is so difficult. It's just that you have not taken your time to go through this thing. You will see that it's very, very simple. So as this is 0, this one is also what? 0, and the exponent is 0. As this is 1, this one will be 1. The exponent here is also 1. As this is 2, this one will be 2. This one will also be 2. So you see that it follows in that pattern. Have you gotten that? So let's continue. If you want to continue, we can continue. So let's write the nth term and the last term, because we don't know, we can't tell the number or the exponent that will be given in the question. So once we are given this exponent, so we are looking at this nth term, so we can write here as n combination. Then let's write here as n minus 1. Then we have a exponent what 1, and then we have b exponent what n minus 1. Let me continue from here, plus n combination what n, and because here we subtract 1 from it, here if we add 1, then this 1 will go, so we have this as what n. Good. Then we have here as a, then because here was 1, if we should subtract 1 from here, then we are getting here as 0. Have we gotten there? Good. And then for the b, here is what negative 1. If we should add 1, then we are getting here as what n. Good. So that is what we are talking about. So always, this is how the combination formula is. That's how we can generate the combination formula. Now this combination formula you see here can also be written in this form. So in some books you may see this, or you may see what I'm going to write. So if you see any of these in any books and you see mine, don't be confused. Don't say what I'm giving you is wrong. It's never wrong, because I've been telling you that in dealing with mathematics, we have so many ways of getting the answer. So if someone uses a different method from your own, it doesn't mean the person is wrong. So this method can also be written in this form. So we can also write it as this. So n and then 0 here. Then we repeat what is here. So as for this one, it doesn't change. So we have a exponent n minus 0, b exponent 0 plus. So once the first one is written in this form, what do you think the second one will be? I know it will be simple for you. So let's move on. So we have here as n 1, and then we have a exponent n minus 1, then we have b exponent what 1. Good. Plus n exponent, then we have n as exponent, then 2 here as the base, then a, then we have here as what this, then b 2. Then we can continue, and then here too we can write here as what n, then n minus 1, then a exponent 1, b exponent n minus 1. And if I should continue from here, I'm going to write n as the exponent and n as the base. Then I have a exponent 0, where b is exponent what n. Let me do this correction here. Here is supposed to be n, not b. So here is also n. So if you don't see this, you may see this. Have you got it? And they are all the same. So if you see this, we are still talking about the combination. If you see this, it is still what combination. Good. So this is how the formula, we can use the combination method to expand binomial. Good. So once you are able to get this formula, or once you are familiar with this formula, then let's take an example and then we look at it. But before that, I want you to note this. In our previous lesson, we made mention that to get the number of terms, you can, what all you have to do is increase what the exponent of the binomial by what 1. So note the following. So we are saying that the number of terms, the number of terms of the expansion is determined by, so the number of terms of the expansion is determined by what? Increasing the exponent here by 1. So that's n plus 1. That's the exponent. So if you want to know the number of terms, you only have to what? Add 1 to the exponent. So if I've given you a question and here you have the exponent as 3, if you want to know the number of terms, just add 1 to 3 and you get what? 4. So it means that after your expansion, you are going to get 4 terms. Exactly. And note also that always the first term and the second term are what? A exponent n and b exponent what? N, respectively. Good. So note that always the first term and the last term or the second term. Let me even make here last term. The last term. Good. So the first term and the last term, whenever you are doing the expansion, your first term is always what? This, because we have the first term here. Have you gotten this exponent? And the last term of your expansion will also be in this form. So let's quickly look at this example and then we apply this method and see how we get it. So let's say you have this, as you have x plus y all to the power of what? 3. So how do we expand this? So we are following this method. It's either we use this one or this one. So I prefer we use the second one. Any of them, you will get the answer. So let's use the second one. So the second one is saying that n, so where we have 3, then we have the base as 3 and my x is 3 minus 3. Then we have our y to exponent what? 3. So remember that I said always you will see that the exponent of the last term or the second term is the same as the base. Have you gotten? So you see that 3 here, 3 here, 3, 2 here, 2 here, 1 here, 1 here, 0 here, 0 here. And the same thing applies to what? The first term. Have you gotten that? So let's quickly do that. So if you use your calculator to kill this, 3 combination 0. So we are getting what? 1 here. Yes, your calculator will give you 1. So 3 combination 0 will give you 1. So 1 times 3x, and know that 3 minus 0 is still what? 3. So exponent x. Have you gotten that? Good. So this one becomes what? So let me write here as, so 1, 3 combination, this is 1 dot what? X cube, and then y exponent 0 will give you what? 1. Have you gotten that? Good. Plus, so 3 combination 1 will also give you 3. So write 3 here dot. Then we subtract 1 from this. We are getting what? X exponent 2, and then y exponent 1 gives us what? Y. Then plus 3 combination 2. Your calculator will also give you what? 3 again dot. Then if I subtract this, I'm getting x exponent what? 1. Then my y is exponent 2. So I'll write my 2 here. Then I'll do the last one. 3 combination 3 will also give you 1. So I'll write my 1 here. Then x minus this is 0. So I'll get my x exponent 0. Then y exponent what? 3. So let's write our final answer. So 1 times this, we are getting x exponent what? Cube plus 3 times this, we are getting this. So we have 3x squared y plus 3 times this, we are getting 3xy squared plus, then 1 times this. So x exponent 0, you know that any non-zero number to the power 0 is what? 1. So 1 times 1, then we are getting what? Y cube. So this gives us what? Our answer. This is how we can use what? The combination method to do what? Binomial expansion. So remember I told you that always the first term and the last term are what? In this form. So you see that this is x and our exponent is what? Cube. and this was y. Our exponent is what? Cube. So the n is our 3, the y is our second term or the last term, and then the x is also what? Cube. Good. So this is how we can use a combination method. So in our next lesson, we are going to use what we call what? Factorial. Good. So see you next time. Thank you.